All right. So yesterday we stopped at step 3 for the Buckingham-Pyle theorem process. Just to recap a bit, what is Buckingham-Pyle theorem? Buckingham-Pyle theorem is one of the methodology that been used by scientists, created specifically to provide non-dimensional parameters or terms, and the theorem, whenever it is non-dimensional, it means it can be used for in many situations, yeah, in many situations and conditions. The usefulness of um, Buckingham-Pyle theorem is very well known. You can read further in the textbook, but what I want to say is Buckingham-Pyle theorem is one of the easiest, not the easiest, but the most common uh, process or methodology that being used to come up with new terms or new equations. For example, like Reynolds number or Freud number, Weber number. There are more. There are quite a few more equations or terms that is dimensionless, but it's combining few dimension. Okay, so I hope you still fresh in your mind with what is dimension, what is unit. Okay, so for a Buckingham theorem, there are a few steps that I mentioned to you, beginning by step 1, which we list down all the variables. Okay, 1 second. Okay, we list down all the variables. For example, like in this case, the steel ball that been released at specific elevation, which is noted as ZO, initial elevation here. Initial elevation here. I'm not sure it's can be seen or not. Okay, yes. So initial elevation, and then the ball, whenever it's released, definitely it will be influenced by the gravitational acceleration noted by G there, and definitely because it's steel ball, they have specific mass, so they have W. Sorry, not W. They have vertical speed. Yes, because why vertical speed is the one that included in the analysis, because um, when you do have vertical speed, then it really depends on the mass of the what is it the ball, and then after the ball touch the atom or the surface of the floor, it will bounce back to the air, and then we will see the elevation of the ball noted by Z. Okay, so we list down everything. In this case, we want to know, if you look at the bottom, they say list of relevant parameters, Z equal to, where is my one? Okay, they have list down everything here. In here, they want to know what is the elevation of the ball after whenever it bounces back from the floor. So Z is the elevation of the ball, which is function of means it's a summation of few parameters, which is first one is time, definitely time. Also WO, which means the initial speed, or in this case vertical speed. ZO and G. ZO is the first or initial elevation of the ball, and the gravity. How do we know all the parameters in this one? If figure doesn't provide a specific W, O, G, Z, and Z, O, yeah, we have to guess, definitely. Second, it's quite common, the figure or questions provide the parameters or the dimension that must be included. Okay, so step number 2, we list down the dimension, the primary dimension of each parameter. So in this case, we list down Z is L. L, remember what is L? L is length. The unit is m meter, but L is the dimension. So L, capital L1. And then T time, WO is what? The vertical speed or initial speed, WO. O is knot or W naught. So that means L over T. And then ZO is L1. ZO is initial elevation. So the unit is meter, but the dimension is L. And then G. G is the gravitational acceleration. Whenever it says acceleration, definitely the T is power of 2. That's why this is careful. This one is T minus 2, power of minus 2. Okay, whenever we list down, then we have a clear picture what are primary dimensions that included in this analysis. So how many primary dimensions here? Yeah, ada 3 kan? 3 primary dimensions. L, T, and only 2. L and T, right? There is no M at all. What is M? M kilogram mass, kan? Okay. And then step number 3, after knowing after knowing the primary dimensions, then we have to have a good guess on the number of pi. So step 3 basically want to have number of pi. Macam mana? Number of pi usually represents by K. Okay. So first we have to guess the reduction of J, because K is equal to N minus J. I just repeat, yesterday I already mentioned this. So as the first guess, set J equals to the number of primary dimension. So bear in mind, they use first guess. Meaning what? It is not compulsory, and it's not the rule of thumb in choosing the reduction J ataupun the number of J. Berapa bilangan J itu, dia bukanlah rule of thumb dia. The J equals to the number of primary dimension. This could be, I will show you later in one of the example in this slide, that whenever we use J equal to primary dimension, it's not valid at all. Okay. So in this case, the Buckingham pi theorem, which is K, is equal to N minus J. So this is the equation. N, what is N? N is number of what? Number of parameters that involve. So number of parameters kita ada berapa tadi? Ada 5 kan? Ada Z, and Z is the elevation of the ball after bounce back to the air, and ada F is not the one that is the parameter. F is just function. Functions ni apa? Function ni kalau kita translate ke bahasa Melayu ni, macam contohnya, it depends on what? Saya berat badan saya adalah bergantung kepada jumlah bilangan makan saya dalam sehari, contohnya. So my kilogram is function of number of meals in a day. Macam tu contoh. So Z is equal to function of what? ZO, okay? Initial elevation, and then depends on what lagi? Initial vertical speed. What else? Time, kan? Berapa laju, kan? Berapa cepat dia jatuh. And then what else? Another one is G. So 1, 2, 3, 4, 5. So this is N. So N. So definitely N is 5, and then minus 2. 2, what is 2? 2 represents the J that is the primary dimension. Kan primary dimension tadi ada apa? Ada L and T only, right? Ni, kita tengok tadi. Ada L and T, tengok. Semua L, T, L, T, L, L, T. There's no more primary dimension that involved in this case. So expected number of pi is equal to K equal to N minus J, which is 3. So we have to have at least 3 pi's. Okay, remember, whenever we have 3 pi's, still not step number 4. Before we touch step number 4, remember when we said ada 3 pi, it's actually pi 1, pi 2, and pi 3. Remember I said yesterday, pi 1 is what? Dependent pi, meaning it's depend on another pi. Pi 2, pi 3 is pi 2 and pi 3 are independent pi, meaning if we write it down, pi 1 equal to function of pi 1, pi 2, right? Because pi 2, pi 3. So pi 1 equal to function of pi 2 and pi 3, meaning whatever value in pi 2 and pi 3, definitely it will affect pi 1, something like that. Yeah. Okay, now we move to the step number 4. In the step number 4, we want to have we want to choose the repeating parameters that we want to use later in the analysis in step 5. So in step 4, we choose J repeating parameters that we'll use to construct each pi. Remember, J represent tadi kita kata, ingat tak kita kata kat sini tadi, reduction J, we set J, in this case we set or we guess J is equal to the primary dimensions, right? So meaning ada 2 je primary dimension dalam case ni, which is L and T, so we set as 2. But in this one they say don't get confused, because I remember previous semester student asked me why J here is repeating parameters. They say because here we agree that J is equal to 2 by guessing the primary dimension. So we want to use the number of 2 in step number 4 to get the repeating parameters that we'll use to construct each pi. Ingat tak tadi kita ada pi 1 ni macam ni, pi 1, pi 2, pi 3 kan? So we want to use 2 parameters from the 5 ni kan, saya tulis balik supaya ingat, Z, O, T and G kan? So dia pilih 2 daripada repeating parameters tu untuk construct each pi. Okay, and then dia kata since the repeating parameters have the potential to appear in each pi, choose them wisely, follow the guideline. Kat mana guideline? Kat sini guideline. Dia kata apa? The 2 parameters that we want to choose will be used repeatedly. Sebab apa? Pi 1 nanti akan guna repeated parameter ni. Contohnya apa nama ni, repeating parameters ni. Contoh kalau kita pilih WO, so WO akan letak kat sini, and then apa belakang dia, and then pi 2 WO, apa belakang dia, pi 3 WO, apa belakang dia. Maksud repeating ni adalah WO, and let's say dalam kes ni dia kata ada 2 kan, and then dia kata let's say kita pilih satu lagi ZO. So sama juga, pi1 ZO apa belakang dia, pi2 ZO apa belakang dia, and pi3 ZO apa parameter belakang dia. So these two parameters are repeating parameters that we want to choose. How to choose these two? Okay, they have specific table for this. This one, you can read further in the textbook. Guidelines for manipulation of pi's resulting from the method of repeating variables. So we can choose based on this criteria. Guideline dia, contohnya guideline yang number 1. We may impose a constant dimensionless exponent on a pi or perform a function operation on a pi. Apa benda tu? Tengok dia kata. Comments dia, we can raise a pi to any exponent. Meaning kalau kita pilih variables tu, it will allow the pi to any exponent, or can allow the pi, ingat tak kata tadi, bila kita pilih ni, kita allow pi ni to any exponent or function in the further analysis. Okay. And few more you can read. Whenever we choose the repeating parameter, it will allow the pi to be multiplied. Whenever we choose the repeating parameter, specific one, we have to make sure that it may form a product or quotient of any pi in the further. And number 4 and 5, you can read later. So in this case, remember we do have Z equal to WO, ZO, T and G. Definitely we will not choose the Z. Sebab apa? Sebab Z ni kita nak cari yang elevation of the ball after dia bounce back to the air kan. Okay, so what left to us is only WO, ZO, T and G. So kita nak pilih macam mana? Ada beberapa benda yang kita kena ikut based on this table, and then we choose WO and ZO because of what? Kita tengok kat sini Okay, ada few things. WO and ZO, we choose WO and ZO first. ZO and Z are the same, so Z cannot be choose anymore, right? So we take out the Z and we take the ZO. How about T? T single one, T not repeating, and meaning T1 ni you tengok tak ada kat lain pula, tak ada dekat dalam parameter yang lain, so it's not repeating, and it can be easily not valid whenever we function with others ataupun kita summation with others, so it's not valid again. Okay, so take out T. How about WO? Kita tengok WO rupanya dia sama dengan G. WO and G gravitational acceleration. Sorry, not similar with G, but the dimension L and T is the same with G. However, the gravitational acceleration is not very common, and sometimes it's not included in many form or terms. So we choose the most common one. So WO is chosen, not the G, and then ZO as well, which is the L1. Okay, that's why in this example they choose WO and ZO. So we go back to the step number 4 again. Okay, so our repeating variables is WO and ZO. Okay, then we proceed. Having WO and ZO, what for? WO and ZO will be used very significantly in the step number 5. Step number 5 ni tuan-tuan, it's not very clear kan, tengok berterabur ni. It's scattered on the page. You may have, if you read in the textbook, it's more clearer, and then it's clearer. It show you step by step and in sequence, but this one is not in sequence. So we generate, in step 5, we generate what? We generate the pi's at a time by grouping the j repeating one of the remaining parameters. So apa boleh kita buat? dalam case ni, first we put pi. Remember, we do have 3 pi, pi 1, pi 2, pi 3. Second, remember we do have what? Repeating variables kan, step number 4. Repeating variables kita adalah apa? Kita ada WO, ingat tak? Kita ada WO and ZO. Betul ke? Yes, betul. Number 3, apa lagi yang tinggal? Number 3, kita ada parameters yang kita tak involve, which is the parameters that will be the function of WO and ZO. Apa dia? Kita ada G, kita ada T. Right. Okay. How about Z? Z as well. So having these three, then kita boleh mulakan analisis kita based on the specific pi. So remember, the first pi here is dependent pi. Ingat tak? Tadi kita bincang banyak kali kan? First pi is dependent pi. So whenever it's dependent pi, it is actually the function of Z. Ingat tak tadi Z kan? Function of WO, ZO, G and T. So Z here is dependent. Okay? So Z, you put the Z here. So that's why Z, very small one. Okay. So Z times WO W naught, initial vertical speed kan. ZO is initial elevation or initial level position of the ball before we release. And then we put A1, tengok ni, ada A1 kat sini, A1, ada B1. What is the function of A1 and B1? Actually, what we want to do with A1 and B1, or maybe C or maybe D, because we want to do the multiplication of the exponents and the division of the exponent. So remember, on the exponents analysis, mathematically, whenever we do have times variable with exponent of something to another variable with exponent of something, whenever the variables are similar, are the same, the exponent is actually plus A plus B plus C, right? Same goes to the division. Whenever you see X, variable X, same, but A and B, right? Same goes to here as well, X. So we can simply do we maintain the variable ataupun the algebra or the terms here, but we analyze the exponent. So division is minus, okay, so division is minus, multiplication is plus. Okay, so for now, knowing this, we can do the analysis of the dimensions. Ini kan kita letak dulu dia punya Buckingham dependent pi. So pi 1 equal to Z WO ZO. Ingat WO ZO ni kalau tuan-tuan tengok, dia WO ZO pi 1. You tengok lagi dekat pi 2. Pi 2 WO ZO. You tengok dekat pi 3. Pi 3 WO ZO. So basically WO ZO ataupun W0 Z0 ni dia repeating variable ataupun repeating parameters in all Buckingham pi. Okay, got it? Alright, good. And then we do the analysis on the dimensions. Pi 1 to analyze the exponent of each parameter. Usually you can have another way to solve this, but this is recommended one, easier to analysis and can reduce the error. So we can do something like this. So we know that only two variables that involve, only two dimensions that involve. Ingat tak? Ada L dengan T je kan? M ada tak? M tak ada kan? Hanya ada L dengan T, length dengan time saja dalam kes ni. Sebab apa? Sebab dia ada velocity, dia ada time, dia ada elevation. So bila ada velocity, definitely ada M dengan L. Bila dia ada elevation, dia ada L dan sebagainya. So only L and T. So they put L naught T naught ataupun L power of 0 T power of 0 equal to Z W naught A1 Z naught B1. Okay, then you can analyze something like this. You put them together. Remember, Z is the elevation. The dimension is L. Meter kan? Jarak. Distance. So we put L. And then L here must power of 1. Kalau dia tak power of 1, yelah power of 1 ni boleh je you kata mathematically dulu kita belajar something that doesn't have any exponent, that means the exponent of 1 kita kata. And but be careful if there's something the exponent of 0, meaning it's equal to 1. So be careful. In this case, you write the 1 here. Put the 1. So L1 represent the Z. WO is what? WO is what? Vertical velocity kan? Initial velocity sebelum ball to release. So kat sini initial vertical speed. So basically unit dia adalah m/second kan? So dimensionnya adalah L T power of -1. So that's why you put L1 T -1 represent WO. You put the bracket power of A1. Ni maintain A1 here and A1. And then after that, you also do the same for the Z naught ataupun initial elevation sebelum ball to the release. So ZO is actually the L and power of B1. And then you do analysis, simple exponent analysis. You do for the T and you do for the L. Time and length. Tengok ni. Time and length. So dalam ni, case ni, remember you put already the T power of 0 here, right? So you write down again T power of 0 equal to mana T dalam case ni? Hanya ada yang ni saja T kan? So T minus 1 A1, ingat tak? So T my power of minus A1. So whenever you do the analysis of the exponent, 0 and minus A1, so 0 equal to minus A1, that means A1 equal to 0. You do the same for the length. Length L naught ataupun L power of 0. Ni L power of 0 ni. So you put down here L power of 0. So L power of 0 equal to L1. Mana? L1 and LA1 and LB1. So you put them all together, L1, LA1, LB1. Okay, and then you analyze the exponent, which is the power of each dimension. So 0 equal to 1 plus A1 plus B1. Knowing that A1 equal to 0, definitely dia kan A1 ni sama aja ni. So this one equal to 0, that means B1 equal to minus 1. And then having this, ni kan tuan-tuan, saya minta maaf, ni sepatutnya kat lain. Ni patut kat bawah. Patut kat bawah, baru nampak sikit. So having B1, so you just write down again. Pi 1 equal to apa dia? Equal to Z. You write down Z ni the the elevation of the ball, W naught, W naught ataupun initial speed, power of A tadi power of A apa? A adalah 0. And then Z naught power of what? Z naught power of B1 ni tadi minus 1. So you do the analysis. Remember, whenever W naught power of 0, that means equal to 1. So this one equal to 1. So it becomes Z, because Z still ada ni, power of 1 kan, over Z naught, because power of minus 1. So we put it down, it becomes like this, exactly same. So pi 1 is equal to Z over Z naught. You do the same for the first independent. Don't get confused. Why they use first independent? Because you want to say that first independent is always pi 2. So pi, first independent is pi 2. Pi 2 equal to T. You may ask me why we start with T. Yes, you can start with G as well. Don't worry. You can start even G first or T first. In this case, they start with T. So T W naught A2 times Z naught B power of 2. You do exactly the same steps. Dimensions of pi 2 equal to L power exponent of 0, T exponent of 0. And then you put down the T here. And they use the T, the big T here. W naught A2 Z naught B2. Kenapa nak guna A2 B2 pula? To avoid confusion lah. Yang tadi kita dah guna A1 kan. So you put them all together. T L power of 1, T power of minus 1, bracket A2, and then you do exactly the same time and length. You get T power of 0 equal to T1 and TA power of 2 minus 2. And then you do analysis on the exponent. 0 equal to 1 minus A2. So A2 equal to 1. And then you do for the length, exactly the same. You got B2 equal to minus 1. When you put them together, basically it becomes pi 2 T W naught A2, mana A2 kita? Power of 1. And then Z naught, power of Z naught kita ni. B2 kita apa? B2 kita adalah minus 1. So that's why TWO over ZO. Macam ni, exactly. Okay, you do the same for the third one. Then you can have, you will get the same equating exponent. Then you get the pi 3. The only thing, the only particular or a bit tricky on the pi 3 is, if you look carefully, apa tadi? Whenever you put them all together, you get GZ naught WO power of 2. And then you have to modify the pi 2 so that it become dimensionless. Why we say it become dimensionless? Because if you look carefully, both of dependent pi 1, pi 1, pi 2, both of them are already in dimensionless. Betul tak? Sebab apa? Tengok Z L over L, kan? So basically T over T. So that dimensionless. And then you look at pi 2. Pi 2 also dimensionless. WO is not weight, careful. WO is vertical speed. So L over T, kan? Ni adalah speed ataupun velocity. M over S, kan? So S is actually T minus 1 times T1 1, over Z naught. Z naught is L, the length. So this one cross each other, L also cross each other. Dimensionless. However, pi3 is not dimensionless. You look. So this one, L t of minus 2, and then L, Z O is L. So W O power of 2 is what? L power of 2 L power of 2, and then T should be, wait a second, G, gravity kita adalah, sekejap ya. No, I was wrong here. Look, whenever we do have this L1 t minus 1 and this one, all the same. Yeah, 1. And then t for W naught is actually already power of 2. So it's already dimensionless. Okay? But we have to modify G2. Sorry, all of them already dimensionless. So I retract my statement just now. I thought that pi3 still not dimensionless, but it's already dimensionless. But G Z naught over W power of 2 naught are not very clear on what purpose of terms that useful in the analysis. So we have to modify the pi3 so that it will be useful. What it means by modify? Modify means that we have to get any closest terms that can be included in the analysis. Do we have it in the, where is the, wait 1 second. No, I didn't insert it, but you please refer to the textbook. Please refer to the textbook on the general terms, the general dimensionless terms that being used in the fluid flow. So in this case, whenever you put power of minus half, minus 0.5, it will give you WO over square root GZ naught, which is equal to Froude number. How can we do this modification? Yes, you have to refer to the table, then get the closest one. And step number 6, we double check the pi's indeed dimensionless. Kan tadi saya cakap, I thought that pi3 is not dimensionless. It's actually dimensionless. So we check in step number 3, we put all of them together, pi1 equal to function of pi2 and pi3, and then we know that pi1 is equal to Z over Z naught, pi2 equal to this one, and pi3 equal to this one. Then you will get the very useful function for the analysis. It's already 4. Okay, you look more examples here. For example, like pressure in the soap, in a soap bubble. Soap bubble here. The only things that try to be highlighted in a soap bubble is that the J couldn't be equal to the primary dimension. If you put primary dimension equal to J, or J equal to primary dimension, then you can have obviously wrong equations. K equal to number of the parameters only 3, but whenever you put the J also equal to 3, then you get K equal to 0. That means pi shouldn't be 0. So you have to manipulate it, reduce to 2, then you can have K pi equal to 1. Okay, then you do the same analysis. Yeah, same analysis. So pi 1 equal to delta PRA1 surface tension B1. Okay, then you can have analysis. You finally get this one. Okay, there are lift of wing. Also, I think friction in pipe. Please read friction in a pipe. Friction in the pipe is very good because very close to our analysis on the flow in a pipe. Do exactly the same. There is no difference at all except the step number 3 on the reduction, and also step number 5, which is if you have to do the modification or not. See, they're still doing the modification so that they get the Darcy friction factor. Okay, how do we know? How can we modify this? If you look carefully, we get only pi 1 equal to tau or the shear stress over rho v power of 2. But this one doesn't provide any information to us. So we check in the table, we figure out that the closest one is Darcy friction factor. We look tau ataupun shear stress over rho v power of 2. We just add the numeric one, which is 8, then it's equal to Darcy friction factor. That's what we call as modification. And then we do the analysis on pi 2 and pi 3, then we get the value 1. Okay, I think that's all. Example of question 5 here, A, B, C, A and B. The B exactly almost similar with the examples that we did in the similarity analysis. Ingat tak kereta and prototype kereta dengan model kereta? You do the analysis on the what? On the Renault number. So Renault number prototype equal to Renault number model. Then you do the analysis. Weber number, this one from the previous, not the last semesters, I think the previous semesters, you can do exactly the analysis. Look, Weber equal to Weber number here equal to L1 rho A V, this one velocity power of P, surface tension power of C. Then you can have exactly the same analysis to get what is A, what is B value, what is C value. Okay, try to do it first. If we do have time next week, I will touch on it again. Then we can conclude that we finish this chapter. Okay. Congratulations to all. You stay with me until we finish this chapter. So I can remark that today we finish syllabus. I will see you again in next week for the solution examples and a few more things, especially on the project. I think that's all for now. Thank you very much. Any question?